Hello and welcome to this little bonus episode. Here we're gonna talk a bit about what is a good search and how do we need to store the data so that we can search them in a convenient way. I'm just gonna update my existing book index with 3 books. All right, and when I search the index, we can see how it looks. And as you can see, we have 3 books in total. Notice 2 of them have the same title, but they all have different author names. They all share that somehow the word king and horse is present, and also we have multiple Steves. So there's a lot of overlap if you just mix it all together. I also added an ISBN number, which always reflects the ID just 3 times the ID. And we assume if a user would search for this ISBN, that would be like searching by an ID. So this should always be a winning match, no matter what else he provides. So what is the basic requirement that we have for search? Let's say we just want to do some search. Gonna create a query. You can choose between a query string and a simple query string. The simple query string is, according to the Elastic documentation, more suitable to exposing it directly to an end user, but I'm going to use the query string because I like the syntax a bit more. And I'm not going to use a default field, instead I'm going to use the fields which takes an array. And I definitely want to search for a title, and I also want to search for the author. That's definitely fields that are interesting for me. And the nice thing about the query string is it already provides a good amount of control what you're searching for. For instance, let's say I'm searching for Stephen King. You see Stephen King is ranked at the top, but also the others show up because this one contains Stephen in the author and King in the title, and this one at least contains King in the title. So what if I would now search for horse and king? They still all show up, and this is because by default all the queries are connected by an OR. So what implicitly is written here would be explicitly like this. It's horse or king in either the title or the author. And of course, this always matches in all 3 documents in some fashion. What I actually want is when a user is searching for a book, I assume that he will most of the time search for the title. So I want that the title is a bit more important than the actual author name. And in Elastic lingo, you can boost different fields. So whenever you have a match in this field, it will get more weight in the search result or result in a higher score, which you can see here. And the score in the end determines the order of the search results. So I want that the title is a bit more important. So I'm gonna assign it a boost factor of 2. And when we search now, we see they're basically all doubled their score, or at least increased their score, maybe not doubled it, but they all got better score because they all have horse in the title. So actually I don't like this default behavior. And the problem with OR searches is the amount of results you get becomes larger and larger when you add more terms, when you add more search terms. So with every word that I put here, I can only increase the amount of results I get. And I think this is actually bad. This is how very old search engines did it. And I think Google was one of the first to understand that actually when you provide more information, the search result should become more specific so that you can narrow down what you're searching for. And you don't want it to be broader and broader, when you provide more information. So that means we naturally want to have an AND connection between our terms. So let's change the default operator to AND. And let's see what this does with our results. So at the moment, we have Stephen King at the top. And yeah, that could be a reasonable result. But what happens now is Stephen King completely disappears, because actually this AND applies per field. That means only, or for each field, it checks, does it contain the word horse and king? So only these two match this. While the Stephen King book can for no field can satisfy horse and king. It can in combinations, but not one field alone can do it. But this also leads to some kind of problem, because while this at the moment is probably a good result, if I would now search for, by the way, if you write in uppercase or lowercase, doesn't matter. So you can just write everything in lowercase. Elastic will transform it behind the scenes anyway to lowercase. So when I search now for Stephen King and horse, let me change that order just to make the point clearer. I actually would expect that it returns this book, because I exactly named the author and I have one word from the title. But since we're connecting them with an AND, and it will check per field if all the ANDs apply and not across fields, we're actually down to 0 results, which obviously is bad. So what we're going to do against that is we're going to copy over all values into like a common artificial field, which I'm going to name all content. And this one does it for the title. I'm also apply the same for the author. And for that, actually need a comma here. And this one is pretty similar to the normal fields. I'm only gonna give it one more parameter, which is the store. And since I've changed the index definition now, I have to recreate it from scratch. So I'm gonna delete it, apply the new one, enter the data again. And I also want to have a look at this new all content field that I just added. So I'm going to use the search endpoint, and I want that it also shows the stored fields, and in particular this all content one that I just created. And here you can see it. These are all the documents that I just entered, and they have now an additional field. This is not part of the document itself, or not of the source part of the document, but it's an additional field that you can search on, and it contains a list of basically all the other fields, like the author name and the title. So now I can include that into my search, and when I reference it here and search for Stephen King horse, then it actually returns Stephen King, as I would expect, and horse, because this all content field now satisfies the AND condition. And of course, this also means that I get some other results, because the all field of this one now also would satisfy it. Okay, so that's already pretty nice. So we have some nice balance between getting results that we can narrow down and not excluding too much. So what I want next is basically if the user would provide whatever name, no matter if it's the author or the title or whatever, and additionally it provides the ISBN, then it should only look at the ISBN basically. So the ISBN is like a unique identifier, and no matter what else, this is definitely the best criteria. And if it matches, then I want it to win. What would not help here, or what would be the first idea, might be, okay, I just put in here ISBN and I give it a very strong boost, something like 10. But the problem here is now we're using AND here. So that means this will basically never match. Only if the user only inputs the ISBN, but then we would have a perfect match anyway. So this is probably not the solution we're looking for, because it will not work in basically any case where the user provides more than just the ISBN. Of course, you can add it just to cover the case where he maybe just puts in something like that. But as soon as you would provide this and something else, you get nothing. Or you could copy that over into the all content field, but yeah, I don't want basically to have this as part of the all content, because it's an ID. So it should be handled like a perfect match. Let's get rid of that. And instead, I want to provide another query that should work together with this query, basically. So to do that, we basically need something to connect multiple different queries into one search result. And to combine multiple queries, Elasticsearch knows some concept called Boolean queries, which are exactly for that, like combining different queries based on different keywords. And I'm going to use the should keyword here. There's also must not, and filter, which all have slightly different meaning, like how they combine with others. So I'm going to paste that in here. Maybe give it a new line and apply some auto indent, which sometimes does not work. Maybe now. Yeah. Okay, that's a bit more than what I asked for. Let's make it a bit less spacey. Okay, and as you can see here, we have an array, so I can provide multiple other queries here. And in this case, I want to have a match query that operates on the ISBN field. And this will have a query, which, of course, this query parameter in the end will always be the same, whatever the user inputs. So I will just manually duplicate it. Of course, in your app, that would be filled by the application. And here I'm gonna apply a boost, and a rather strong one. Let's check first what happens here. Okay, this of course matches perfectly, and you can see the score is very high. And if I would extend it now with Stephen King, which is not the correct author, but anyway, this ISBN number should basically dominate the search no matter what. And you see, it still outputs this result, which is now only based on this query part, because this alone would match, would not produce any match. Showcase it here, so that breaks it, and that makes it return something. So this is a very special case, I would say, where you match on an ISBN. That's probably the easiest one, and not so common, because the user will probably not know the number. But if he knows, of course, you want to return a perfect result. But what happens if the user has small typos? Like, for example, let's put it actually at the end, because it's often called Stephen King's The Shining or whatever. And this also causes a problem, because it returns 0 results. And there are different ways how we can deal with that. Because we use here the query string, we can actually, or not we, but basically the user can add this little tilde sign here on each term that he wants, and that makes it a fuzzy search. And fuzzy search basically allows to correct small mistakes, like one letter too much, or one letter too little, or one letter wrong, for example. It would also work if he just forgot this one. So it will still return something. But I think that's unreasonable to expect that the user basically has to be aware that he might have done an error and put this consciously. And I think that's not a nice user experience. So we cannot expect that the user will put this into place. So I want to have another query that is able to handle such cases. Unfortunately, the query string cannot be activated to use some fuzziness on all terms, but other queries can actually do it. So for this one, I'm going to use a multi-match, and the query here, of course, would be the same, whatever the user types in. And I would use the same field construct. So I'm just going to copy over this array. And here I can actually activate the fuzziness. And I'm going to set it to auto, which means, which basically means longer words can have a fuzziness of 2, meaning the algorithm will accept 2 changes of characters, and words between 3 and 5 characters will only have allowed fuzziness of 1. And everything below 3 will not have any fuzziness, or will not match with fuzziness. And here we see this, of course, is like the weakest query that we have, because it's an OR connection and it's fuzzy. So this will probably be the slowest and return rather low quality results. So I actually want so that everything that this query finds should have a negative boost. So I basically apply like a penalty and say, okay, you're multiplied with a factor of 0.5. That should decrease their value here against the other twos. So let's run it again. And you see their scores are basically only the half. So that's it basically for this little search optimization. We have given the user a way to search for a unique identifier, which will basically always dominate the search. He can narrow down the search with an AND logic. So when he provides more information, the search will get stricter. So he can narrow down the search, but we also implemented some fallback in case that the user made small errors, or that we cannot find stuff with such strict AND conditions. Then we basically fall back to some OR conditions and also apply some fuzziness on top. So if we don't find a good match, that we at least can return something, and maybe the user can from there improve its search. So that's it for the searching part. That should be very easy to transfer into our Quarkus app. You can basically just copy over the stuff that I did here and paste it into the classes, into the Elasticsearch service classes that we already created. And yeah, then you should be basically good to go. So see you soon.